Hi, my name is John Ball. I'm a rising senior physics major here at the University of Maryland College Park, and I'm incredibly excited to show off to you my personal favorite demo from the University of Maryland Physics Lecture Demonstration Facility, the Can Crusher. Actually, it is so much my favorite that I brought with me a hard copy of the original 1994 paper that describes the construction and operation of this machine. So let's start by going through the various parts. So at the heart of the Can Crusher is a giant capacitor, which is this large red box here at the bottom. It is a 400 microfarad capacitor that can be charged up to 3,000 volts. And on top of that capacitor is a spark gap switch. So inside there are two pieces of metal, and when we lift the actuator switch, we bring them close enough that a spark can form, and we can discharge the energy inside of the capacitor. The energy then flows from the capacitor through the coil, which is this compacted object here at the front where we have 3 turns of very thick copper wire, which the current quickly discharges through. We also have a DC voltmeter to measure the voltage across the capacitor so we know when it's done charging. And in the back of the device, we have a large high voltage power supply to charge up the capacitor. So now I'm going to load the device. So I'm going to start by retrieving my soda can of choice. In this case, it is a retro-designed Pepsi can. And I'm going to open the 2 ports on either side of the device, the acrylic housing, and then I'm going to wedge the soda can inside of the coil pack here. All right. And now I am ready to start charging. So I'm going to put on my headphones and make sure that no one is in the line of sight of our can. I'm going to plug our demo in. And I'm going to turn on the high voltage charging power supply. And now I can start watching the DC voltmeter as the capacitor begins to charge. Once that DC voltmeter hits 3,000 volts, we will be ready to crush. All right, and we're now just touching 3 kilovolts, so I'm going to turn off the power supply. I'm going to ask everyone to cover their ears, and we're going to crush a can in 3, 2, 1. And we can see that our soda can is blown apart, and if you could feel it through the camera, you'd know that it is warm, as so much energy was used to split it in half. So here we have our final result. I'd say that can was quite properly crushed. So to understand what's happening inside of the Can Crusher, we need 2 physics concepts, the first being Faraday's law of induction, which tells us that a rapidly changing magnetic field generates a spiraling electric field. And we're also going to need the Lorentz force equation, which tells us how charged particles, like electrons and protons, feel forces as they interact with electric and magnetic fields. In particular, we're going to be interested in the description of how a charged particle moves inside of a magnetic field. And what this is telling us in mathematical language is that the force felt by a charged particle moving through a magnetic field is perpendicular both to the direction of the magnetic field and to the direction that the particle is moving. So, keeping that in mind, let's go over here and take a look at a diagram of our Can Crusher. So we can see we have all of the basic components of the Can Crusher. We have a big capacitor, in this case charged to 3 kilovolts. We have a switch that lets us connect the capacitor to our coil. And we see we have a big coil here with our aluminum can in the middle. So once our capacitor is charged and we're ready to crush the can, we can close the switch. And when we close the switch, a huge amount of current starts flowing through our coil in a particular direction. And as that current begins to flow, it generates a massive magnetic field. So now we have a huge magnetic field forming in this direction into the can. And this massive magnetic field, through Faraday's law of induction, we know as it's rising is going to generate an electric field. And so now we get an electric field pointing in the opposite direction to the direction that the current is flowing. So now, inside of the can, as our magnetic field forms, an electric field starts forming in this direction. And that electric field causes a current to flow inside of the aluminum can as well, but in the opposite direction to the current that's generating the magnetic field. So now, we have a current flowing from the capacitor. It's causing this huge magnetic field to form very, very rapidly. That rapidly changing magnetic field is causing an electric field to form by induction inside of the soda can that's flowing in the opposite direction to the current coming from the capacitor. And now we're ready to use the Lorentz force equation. And what the Lorentz force equation is telling us is that the force felt by charged particles in a magnetic field is going to be perpendicular, both to the direction they're moving and to the magnetic field. So if we think about it, the electricity, the current flowing inside of this can is made of electrons, and those electrons are charged particles, and they are now in the presence of a massive magnetic field that's been generated by the current flowing from the capacitor. And so now they're going to start feeling a force, and that force is going to be in a direction perpendicular to the direction they're moving and to the direction of the magnetic field. And the direction of that force is inward. And for every electron inside of the soda can, it feels this huge inward force generated by the presence of this strong magnetic field and the direction of their motion. And it's that massive force that causes the can to crush down and implode on itself. And if we do it with enough current and a strong enough magnetic field changing fast enough, it pinches so strongly it causes the can to fly apart. And that's how the can crusher works. So thank you so much for watching our video. We hope to see you back again here soon.